This is day 14 video, which is for Wednesday, April 15th. Today we're going to begin solving solving trigonometric functions. Little review here real quick before we start. We all know, we all know that the sine of 30 degrees is equal to 1/2. And then I think we've done this before. If I take the inverse sine, I have to do it on the left, of both sides, the inverse sine of the sine, being inverse functions, gives me the 30 degrees is equal to the inverse sine of 1/2. So basically it's a unit circle just going backwards. And of course, inverse sine can also be rewritten as arc sine. They are the same exact thing. So the first equation I want to solve is just basically that. X, gotta get my pen, X is equal to the arc sine or inverse sine of 1/2. You take the inverse sine of a number and we're going to get an angle. So that's why this says find all values on the interval from 0 to 2 pi. And notice it's non-inclusive on the 0 side, inclusive on the 2 pi side. We don't want to repeat that positive x-axis. That satisfies this equation. So basically what this is asking is, what angle has the sine of 1/2? Well, we just showed that pi over 6 has the coordinates √3/2 and 1/2. Therefore, the sine of pi over 6 is equal to 1/2, or the arc sine of 1/2 is pi over 6. But between 0 and 2 pi, that's not the only place that is true. If I come over here to the second quadrant with a reference angle of pi over 6, it has the coordinates of negative √3/2, positive 1/2. So that would be 5 pi over 6 is also an angle between 0 and 2 pi that satisfies this equation. And there's not going to be anywhere else in here that's true, because in the fourth and third quadrants, the sign is negative. There's going to be three ways that we're going to solve trigonometric equations. One is the principal values, which we don't know anything about yet. The second will be this on a given interval. And the third will be infinitely many, because if I just let this go beyond 2 pi, I would come back here. Now 2 pi is going to be 12 pi over 6. So my next answer would be 13 pi over 6. And so forth and so on. So there'll be infinitely many. And we'll write those the way we did for the asymptotes in the domain of the secant and the cosecant and the tangent and the cotangent. But for right now, we're going to start with this one. We're finding them on the interval. There can be one, there can be two. And that's how we're going to do them. Okay, so how we're going to do these equations, it's pretty simple. If you know your unit circle and you're at home, so you can probably get your unit circle. I tried and beg you to use without that. Make sure you just draw your little x and y axis. We're going to say, okay, we're looking for the inverse cosine, or what angle has the cosine of negative 1/2. The cosine is negative in the second and third quadrants. We just have to figure out what the reference angle is. Well, the cosine is going to be the x-coordinate. That's negative 1/2. That's positive √3/2. This one's negative 1/2 and negative √3/2. And that's going to be a reference angle of pi over 3, or 60 degrees. So my first answer is going to be 2 pi over 3. And then this one would be 4 pi over 3. And it all has to do with just how well you know your unit circle. That's all there is to these problems. All right, this is about as hard as they get. We're looking for the values of x that satisfy the inverse cotangent is √3/3. I'm going to draw my little x and y axis here, but let's just go over here just for review. Pi over 6, 30 degrees. Pi over 3, or 60 degrees. So if I'm at 30 degrees, it begins with a 3. It's root 3 over 2, 1/2. And then the third out here is going to be lots of 3, so it's root 3 over 3. At 60, it doesn't start with a 3, so I start with the 1/2, the root 3 over 2. And since it's not a 30 or a 3, then it just has 1 3 here. Now these are the tangent out here. So I'm looking for the cotangent, which is the reciprocal of these guys. Well, the reciprocal of this one will be the root 3 over 3. And the reciprocal of root 3 over 3 is going to be root 3. All right, so basically what I'm looking at is the cotangent. Where is the cotangent positive? The cotangent is positive in the first quadrant and in the third quadrant, just like the tangent. Because x is positive, y is positive, the cotangent's positive. X is negative, y is negative, the cotangent's negative. I'm looking for a reference angle here of root 3 or 60 degrees, because that will give me my root 3 over 3. And this one also is going to be a reference angle of the pi over 3, because that will also give me the positive root 3 over 3 for the cotangent. So my answers are going to be pi over 3, and this would be 4 pi over 3. Okay, last example here, I'm going to do the arc cosecant of -2. So the cosecant is the reciprocal of the sine. So basically we're looking, where's the sine -1/2? Well, the sine is negative over here and over here. Now, what reference angle has the sine of 1/2? And that is going to be a pi over 6, or 30 degrees. So this one here is going to be 6 pi over 6 plus 1, or x equals 5 pi over 6. And over here, that's 1 less than 12 pi over 6, so we're looking at 11 pi over 6. All right, I think that's enough examples for you. What I'm going to do is I'm just going to write out 4 problems here for your homework. So number 1, let's do that x is equal to the arctan of 1. Number 2, x equals the inverse secant of negative root 2. 3, x equals the arc cosine of root 2 over 2. And finally, number 4, let's do x is equal to the inverse cotangent of root 3. All right, so that will be your 4 homework. You know what? Let's do another one. This will also be in radians, because each one of these is in radians. The same instructions apply up here that I did with these examples. Let's do this one, but this one you're going to have to use your calculator because it's not a special angle. Remember, it's in radian mode. Let's do the inverse sine of negative 0.73. All right, so there's your 5 homework problems. If you're working on, ask me questions on the Google Classroom. And there you have it. Have fun.